In this video, I'm going to introduce the basics of the SQL query and then also just some introduction to working in SQL Server through SQL Server Management Studio specifically. So the first thing to kind of talk through is data and how it looks in SQL. The screenshot below is from SQL Server, which is going to be the default that I talk about throughout the course. So when I mention SQL, it's really Transact SQL, the Microsoft procedural extension to the SQL language. And so the data is stored in a two-dimensional table with rows and columns. And so if you look at the table below, right, we have our columns across the top and our rows descending down vertically. And so columns are typically referred to as fields. So address ID is a field, address line 1 is a field, address line 2 is a field, etc. And then columns also have these field names, which I just referred to for the first three fields. And then also, just to point out here, city is a field name for this particular field. The rows, so across horizontally, are records, or they're sometimes referred to as observations, particularly in analytics settings or modeling settings. And they don't have names, but you can see that they do have over on the left-hand side. It's kind of unusual, I would say, to have the data match up exactly with the row. The row kind of I don't want to call them names, but the row identifier on the left, which is independent of the actual table. This field name actually, when you select the top, the first 50 records, it actually pulls a field that matches one-to-one, at least for the first 10. So that's kind of an anomaly there. But you can always see, which record you're referring to through the table on the left. And then this is the query. This right here is the query that ultimately returned these records here. So it's basically selecting the top 50 records from this particular table, which we'll get into the syntax there later. And so talking through the SQL query itself, here's an example query up in the top right. But most queries are transactional. So when you run a query, it actually doesn't affect or change the underlying data that you're querying. Now with the procedural extension, it is possible to manipulate, to alter, update the data that's in the SQL Server. In a work setting, you might be restricted from doing so, right? So you might only have read access to certain tables to prevent you essentially from manipulating or corrupting, I guess, the data. And so what the query is basically just a command to return certain elements that are specified within the query. And clauses, there are various clauses for that can appear in a query, and they modify the query. Certain clauses are optional or required. And so if you look at the top, the query, we're saying select count star city from this kind of address, right? It's a table reference essentially, where a particular field, the value for a particular field is equal to a certain number, and then we're grouping those counts by values in the field city, and then we're also ordering the output by that field. And so that's essentially the nuts and bolts of the query right there. However, now these can get much more complex, and that's why there's an entire course here devoted to it, and there could be quite a few more. All right, but just to review the clauses, the primary clauses, the select clause is obviously your first clause here, and it basically tells SQL what to return. What follows the select clause, the select list, is basically a list of elements that you want SQL to return. The from clause is optional, but it's almost always going to be used in any practical setting because you ultimately the from clause tells SQL where to pull the data from. And so in this particular example, it's an address. The table is named address in the schema person from the database AdventureWorks 2017. There's also a group by, I'm sorry, I skipped one. The where clause is optional, but this is essentially your filter. So you can filter in and out records from the query based on certain criteria or logic. The group by clause essentially aggregates. It's used with aggregation functions, and it's essentially it tells SQL what values or what distinct values from a particular field to aggregate across. The having clause is used with the group by clause, and that's the only place that it's going to appear. I'm not going to kind of talk about what the differences between the having or the where here, but this is just high level, kind of introducing you to the various clauses that you're going to see in the SQL query. Then the last clause here is an order by, which is essentially simply a sort statement that tells SQL how to return the records, or more specifically, in what order to return the records. So I'm going to toggle between the PowerPoint and then also SQL Server Management Studio. But one easy way to explore data without even having to write a query is to auto-generate a query by finding a table in the Object Explorer, right-clicking it, and then selecting the top 1,000 rows. And we'll do that now. But you'll basically see that a script is auto-generated from SQL Server Management Studio. Head over there. You can see I'm not connected yet, so you need to connect to your server, and so automatically populated. We'll click connect, and then we have obviously these various nodes here. You won't really, I mean, I've been using SQL Server for a long time, and I've never really gone outside of the databases node. The other ones are really for kind of database administration and data, configuring the way that the data is stored and users, and the way that users access it. So when I expanded the databases node, the AdventureWorks database is underneath it. And I'm going to expand that, all right, and we have these various nodes here. So we have a tables node, which is where your data is going to be. There's a views node. I'm not going to talk about anything outside of the tables today, but just pointing out some that will or could potentially be useful in your future. And then the programmability node has stored procedures and then also functions. So if we expand the tables node, we'll see the tables associated with the AdventureWorks. The one that I have on my machine is a 2017 version. You might have a 2019 or even a 2016 version. It doesn't matter, that they're all the same. It's just more the year is important for the way that the SQL Server is configured and whether or not it's compatible. So as far as I know, the data is all the same. So we're gonna, each one of these is a table here, and so we're going to go to the person dot address table and right click, and then you'll see you have an option, select top 1,000 rows. And so when I click this option, a script is automatically going to be generated. And so this is the query script up here. And then in the output window, the output is automatically, the query is essentially run and the output is displayed. And so if we look at the query, it's basically saying select top 1,000, which essentially means the first 1,000 records for the fields, in the select list. So these are all the fields that are actually in that particular table listed out, and then it's telling you from, fetch all top 1,000 records for all the fields listed in the select list from this particular table. And so you can start exploring the data, right, and see the various values for particular fields, and how those might differ, or it essentially gives you a sneak peek into the data. So it's a very useful tool. I use it all the time still, just to see, if I forget what a field name is, it's useful to kind of do that and search for a portion of it so that I can find the particular name. Because when you get into I'm not saying that this is the way that it works everywhere, but certain companies, these tables, have fields that, call it 50 fields or 75 fields. And so sometimes remembering the way that it was named or the way that it's carried over from a particular system can be a source of frustration. So the select top 1,000 rows has always been a useful tool, and allows you to, again, explore your data. Heading back to the PowerPoint. Going to talk through another thing that we actually saw in the last query that was auto-generated for us, but something I didn't point out at the time. So you'll see that this portion up here at the top that was auto-generated, that the color is green, and so by default, comments in T-SQL or SQL Server are green, and so these comments, this comment up here, is ultimately not run when you tell the SQL Server to execute the query. And so comments in general are useful in code, in coding and programming, to let someone else know what you're doing and or send your future self some notes on what you're doing. And so there are really two ways to make comments in T-SQL. We saw the first one here. I'll talk about it in a second. The inline comment is basically made with two dashes. So we have two dashes here, and then the comment, you see it's displayed in green, which means that this portion of code ultimately is not run when it's sent to the compiler. Then there's another way to comment, which is essentially the form that this query, or the comment in this query, took, and that's using a / and asterisk to start the comment. The comment can go across multiple lines, and then it's closed with an asterisk and a / again. This particular comment, inline comment with the two dashes, means that if I were to go to another line and didn't have the two dashes, it would no longer be a comment, and so SQL would treat that as if it were code. And just to see an example in practice, we have the one method of commenting that can span multiple lines up to the top. So we have a select top example, is what the comment reads. And then the query itself, if you navigate around, read around the green text, you'll see select top 10 from this particular table. So it's just saying select the top 10 records for all fields from this particular table. You'll see there's an inline comment here. You can ultimately place these after code on a particular line. And then you can also see that, and unfortunately this text kind of didn't carry over the way that I wanted it to, so I'm just going to manipulate it real quick. So this is the way the original code was written. So what I wanted to show here is that this method, while I say across lines, it can also be used in line as well. So you can see it, you could use it in this syntax in the same way that you use the inline commenting method with the two dashes. But this is the one that ultimately can span multiple lines, because you basically tell SQL where the comment starts and then where it ends. And then finally, we're just going to kind of write the most basic of queries, which is basically using SQL as a calculator. And so you can see in the first example, we tell SQL to select 3 plus 1. The output is going to be 4. And so we're going to transition over to SQL Server Management Studio here in a second. The other thing I want to point out is that SQL does, kind of what you would expect. It obeys the order of operations. It also supports, as we saw in this particular query, it supports multiple items to select using the query. So in this particular example, we're selecting or returning both the result of this mathematical operation, 1 plus the product of 3 and 2. And then it will also return the result of this mathematical operation, which is the product of 2 and 2, added to the product of 3 and 3. One note here, and it's probably more tangible when you actually see what it outputs. In SQL, and excuse me, and just in general for programming languages, data types are ultimately treated differently. For example, T-SQL will basically return if you do anything with only integer data types, the ultimate result or the default result is an integer data type. So what does that mean when we divide an integer by another integer? It's going to return an integer. So by definition, an integer can't return any decimal precision. And so what the practical result is that you'll see any division kind of quote unquote rounded down. It basically truncates the decimal. Even though that's not technically what it's doing, because it's just there is no such thing as a remainder or decimal with integer division, but that's kind of the practical result. The one way around that is if you were to basically force a different data type on the particular number. So in this example, we add a decimal to 3. And basically the data type precedence takes over. So if there's an integer and a type of number with a decimal, the result will be a number with a decimal. So that's kind of something to keep in mind as you use SQL more, because it can be frustrating. It can ultimately give you results that you're not expecting and or lead you down incorrect paths when you're performing these operations and kind of don't recognize the ways that they can be limited. So we're going to switch over to SQL Server Management Studio again to explore these concepts. I'm going to create a new query. So there's a new query window up here. And we're essentially just going to type out some of the examples we saw. So one of those was select 1 plus 3. And I'm going to highlight the code to run it and press to execute. You can also press F5. That's the hotkey or the shortcut. And so we see the result here is 4. And you'll notice that there is no field name with the output. It says no column name. Where when we pulled back, the specific column names or field names from this table, they were ultimately displayed. And essentially, we don't have a column name here because we didn't tell SQL what to name the column in the output, which we'll cover at a later point. So I'm not sure what the exact example was in the PowerPoint, but it's something like this, right? And so you'll see when we run this code again, I highlight it to execute it. You'll see that we ultimately get two outputs, essentially 2 fields. And one is 7, so 1 plus 3 times 2 by the order of operations would be 7. And then 2 plus 2 plus 3 times 3 is 4 plus 9. And so you can see SQL will return the correct result here. Then if we go to integer division problem, so let's just take 1345 divided by 3. You'll notice that this doesn't divide evenly, right? So if we execute this, we'll get the result of 448. If we do it and add a decimal, or ultimately we can put these two things together, a single select statement or clause, you'll see that essentially in this particular example with integer division, the decimals are not included. Any numbers that come after the decimal are not included, and that's the case even if you were to go up a couple. I think this will do it. Oh, that was evenly divisible. I should have done. So in this particular example, the 1347, because it's ultimately divisible by 3. You'll see that the results are equivalent. But when I force it to 1346 divided by 3, you'll see that the practical result, right, is that the number using integer division is rounded down, whereas typical rounding, you would round this up to 449. These particular examples aren't right. I mean, you're kind of like, okay, well, if you have integers and the result, that's not really going to change the answer or whatever you're after too much, right? But where it does come into play is with ratios or not decimal, percentages. So for example, let's just do 1 divided by 3. And if you're kind of thinking of what that will be, just imagine that there are no decimal places. And so a decimal answer would be 0.3333, right? 3 repeating. In this particular case, SQL is going to return 0. And that's because essentially 1 divided by 3 can occur 0 times under integer division. If we force it to have decimal precision, or coerce it is a common programming term for that, you'll see that we can ultimately return those. And so if you're working with ratios and you're ultimately using ratios to then multiply by, let's say 24.3. See if this works as I anticipate it will, right? You ultimately get the result of 0.0. And so that's not what you would typically expect, right? And so this is why you have to be careful with that, because this is going to be performed first. The result is 0, and then it's going to be multiplied by 24.3. And so with that, I think we've covered kind of the introduction to the SQL query and how to take a sneak peek at some of the tables in a database, and then also just some basic calculations with the select clause.